Hey there guys, Paul here from theengineeringmindset.com. In this video we are going to be looking at the air handling unit filters of a HVAC system. Now when you open up AHU you'll find the filters looking a bit like this. Now these are two different sets of filters, and you can see here we've got ones which are known as the primary and we've also got ones known as the secondary. And these both have very different functions in your air handling unit. Now in your AHU system, where you've got your supply AHU there and your discharge or extract AHU here, your filters are going to be before any of the heating or cooling coils and the fan, and should be just after the dampers. If you've got air recirculation happening in your AHU, where some of the discharge air is recirculated back into the fresh air intake AHU, then obviously your filters need to be downstream of this to filter all the air which is coming through and is going to recirculate into your building. Now the primary filters, which look like this, they are there to catch the dust. They're typically made in this pleated design, which increases the surface area and allows it to catch much more dust and last a bit longer than say if it were just a flat sheet. And they're usually made from a synthetic material with a cardboard outer frame, and they're held in shape with a wire mesh. And depending on the size of the AHU, you'll usually have to buy your filters in these pre-made sizes, and these will come and fit as filter banks within the AHU. Now you should be able to just pull the filters out like so, or they might have some sort of latch like you can see here, and you just twist these and this will allow you to pull these out in the direction of airflow. So this is a close-up of the filter material there, and these primary filters, they're pretty effective at catching dust particles down to around 4 or 5 microns, but they can't really catch anything less than say 1 or 2 microns. Now this is a dirty filter, as you can see, it's absolutely covered in dust, and this has taken a few months to build up to this level, but that does depend on where your air intake is located and where your building is located. If you're in some busy industrial unit, then obviously it's going to be probably a lot more dust than say if your building intake was near the seaside. And the reason you want to stop all this dust is obviously because it's going to be entering into the building and all the people in there will be breathing this dirty air in. So you want to stop that. But you also want to stop the dust entering further into the AHU, as this will stick to the fans, the motors, the cooling coils. It's going to build up along the inside of the ductwork as well. When you start to get all this dust accumulating in your ductwork, then the fans need to run a lot harder to get over that pressure drop from the resistance that it causes. If too much dust built up on the motor or some of the mechanical parts, then it could even potentially cause a fire also. Sometimes if you're using some expensive filters, then these pre-filters, primary filters, are placed in front of them to try and reduce the amount of dirt and dust caught by the expensive ones, and that lets them last a bit longer, whereas these primary ones are fairly cheap and they can just be thrown away. Now on the side of the primary filters, you should have some details on there about who the manufacturer is. You'll have an order number there so you can track it and reorder it. You'll also should, if it's a good manufacturer, have an arrow indicating the direction of the airflow, and you've also got some dimensions there for the size of the filter. Now the other filters which we're going to mention is the secondary filters, and they look a bit like this. So these filters are there to catch pollen and bacteria and also some other dust which wasn't caught initially by the primary filters. Now these are typically a bag filter type made from a synthetic material, and as you can see they extend backwards a short distance and they will inflate a little as air passes through them, and that gives them a very large surface area. So you obviously got the surface area of this side and then on the other side of that as well, so we can capture a lot of air and a lot of particles in that air. Now I'll just show you an example of a clean filter, bag filter here, the secondary filter. So as you can see from the material, it's very soft and it extends quite some way back. It's completely movable also, and these will inflate as the air passes through them to capture a lot of dirt. and I'll just show you a dirty version. So this is one that's just been replaced. As you can see, it's absolutely filthy on both sides. It has caught lots of dirt and pollen from there, so this has been very effective at catching all the pollen and dirt, bacteria, etc. in there, and these will be disposed of as well. And this has taken somewhere between 3 to 6 months to accumulate to this level on this particular building, that is. Now, as the filters pick up that dirt, they do create a lot of pressure resistance, which the fan has to overcome, and that's obviously very energy intensive. I'll just show you a clip here. So here we've got the dial, which is reading in pascals the amount of pressure difference across there. So we've got the high side pressure there and the low side pressure there. And the high side reads the face of the bag filters there, so the air is passing across and into these filters, and then it's coming out on the other side through the filter bags there. So that pressure difference, which you can see here, is around 145 pascals, and that means the bags are they're fairly dirty. So probably around 200, maybe 250 pascals, the bags will need to be replaced. But you should speak to your manufacturer to find out what the pressure difference should be across the filters in your AHU, as they do vary. Now, the filters do vary by energy efficiency, set by different standards. So the higher efficiency ones will create a lower pressure drop, and that means that your fans can overcome that pressure a lot easier. Well, there's just less pressure to overcome, and probably the fans driving this are going to be around 5 to 10 kilowatts, and they'll be running maybe 12 to 24 hours a day. So there's potentially a lot of energy you can save just from switching to a more energy efficient filter. Alright, that's it for this video. Thank you very much for watching. Don't forget to subscribe, like and share the video. Any questions, please leave them in the comments section below, and we'll try to get back to you as soon as possible. Once again, thanks for watching.